So let's then deal with supplemental problem 4.2. You can find this problem in the course ebook in the Chapter 4 Supplemental Problems on page 1. Suppose I have a 60 Hertz frequency. That would correspond to 377 radians per second. Can you find the time domain functions for the following phasors? -5 plus J5, -4 minus J3, 5 minus J12, minus J5, and 6. Because these are in rectangular form, we have to convert them to polar form to transform back into the time domain. -5 plus J5, we'll take the square root of the real part squared plus the imaginary part squared to get the magnitude. That turns out to be 7.07. The angle is the arctangent of the imaginary part, which is 5, over the real part. And that turns out to be 135 degrees. We can check that with our function here. We have something that's in the second quadrant, and so that's consistent with that. Convert this into the time domain. We're going to take the magnitude, and then take the cosine of omega t, and then add the angle. 7.07 times the cosine of the quantity, 377t plus 135. For our next function, we'll take the real part squared plus the imaginary part squared, -4 squared, and then -3. We don't square the j, and that turns out to be 5. And the angle is the arctangent of the imaginary, which is -3, over the real, which is -4. That's a minus 143 degrees, and that's in the third quadrant, which is consistent with this. Our transformation becomes 5 times the cosine of omega t minus 143. Next one is 5 minus J12. Real part squared, imaginary part squared, square root gives me 13. The arctangent of the imaginary term over the real term is a minus 67.4 degrees. That's in the fourth quadrant, and that's consistent with the fact that we've got a positive real part and a negative imaginary part. So our time function is 13 times the cosine of omega t minus 67.4 degrees. Next one is just minus J5. Real part is 0. Imaginary part is -5. Squaring that and square rooting it, we get 5. Take the arctangent of the imaginary term over the real term, and that's going to go off to infinity. But we're between the third and fourth quadrant, and so we'll be looking at a minus 90 degrees. Our time domain function is 5 times the cosine of omega t minus 90 degrees. Lastly, 6. Real part squared plus imaginary part squared, square root is 6. Arctangent of the imaginary term, which is 0, over 6 is 0, and that's 0 degrees. Just 6 times the cosine of omega t. One last comment. In doing this problem, I was doing the definition of magnitude by taking the square root of the real part squared plus the imaginary part squared. But that takes time. Likewise, finding the arctangent of the imaginary over the real, this minus sign needs to be in the right location. Sometimes you get an answer that's off by 180 degrees. I recommend getting a calculator that can do rectangular to polar or polar to rectangular conversion. So what you'll be doing is entering in the real part and the imaginary part, so 2 keystrokes, hit a function, and then hit 2 keystrokes to get the answer out. Every calculator is a little bit different, so you need to get that manual that goes with your calculator, perhaps find it online, but you'll need that for being able to do the test problems. Doing this definition is just too slow. And this is supplemental problem 4.2.